have for doing that and sort of why one might be better than another. And we will have some Q&A at the end. If you think of some questions along the way, feel free to go ahead and put them in the chat box, and then at the end we'll try to address as many as we can, and then from there. All right, so let me actually take the video off there. Cool. And so one URL I want to put up right away is this GitHub URL. So if you were to go there, what we have is all of the projects that I'll be showing during this webinar. And so if you'd like to get the code and things like that, and also I've put some useful links up there as well. So it looks something like this. So we've got a few links here which I'll talk about along the way. I also put a link at the bottom there to the 2-day virtual training that's upcoming, and then again some projects here that we'll be looking at along the way. And I think what I'll also do is I'm going to go ahead and just grab this, make it a little easier, and I'll throw this in the chat box. Make it easier to get there. Cool. Okay, so first thing here, mobile landscape. So who are the users that we potentially want to target? So iPhone is definitely the most popular device by quite a large margin. However, all the other devices, whether it be Samsung or LG or whatever, tend to all run the Android OS. So if we can focus on iOS and Android, we'll manage to pick up probably 96–97% of our mobile users out there. Now, when it comes to Windows devices, it's one of those things where it's not a very large percentage of our user base, but as a developer, if you're like me, you think, well, if I can pick those up for a small amount of effort or no effort at all, then I'm going to do that. If it's going to require a huge amount of effort to get that last 1%, probably not as interested. All right, so we can see it in numbers here too. Again, Android plus iOS, we're looking at around what, 98–99%, something like that at this point. Okay, so when we're talking about Xamarin during this webinar, we'll be focusing mostly on Android and iOS, but I will mention Windows devices as well and UWP apps or Universal Windows Platform. But as we'll see with Xamarin, it can be pretty easy, depending on your application, to go ahead and pick up that last 0.5% or whatever, right? If we can do that with not much effort, why not, right? More users. All right, so options, right? We've decided we're going to develop a mobile application. We're going to support multiple platforms. How are we going to do it? Well, one option, obviously, is we can build native. You may end up having to build the app 3 times or 4 times, but there are some advantages to that. All right, you'll get the tools and the languages that the platform developers really intend for you to use. You'll get good performance, but again, if we can avoid writing all that stuff multiple times, that's a benefit. So native Android development, if you talk to Google, they'll say, well, we want you to use Java, we want you to use Android Studio. So I actually want to just bring it up here briefly, just because I want to kind of compare the experience you get with Xamarin versus if you're doing it native and some of the options. Because one of the questions I would have if I'm choosing between native or Xamarin is, what do I gain? What do I lose, if anything, right? So here I am in Android Studio. So this is our native experience. And if I was to create a new project in Android Studio, I get to pick my application name, you know, something that's going to generate my identifier to uniquely identify my app, things like the minimum version I want to target. So this is an important decision no matter what we're using to build our mobile app is, you know, who do we want to support? So, and as you can see, the experience in Android Studio is here kind of nice, because if I pick something really high, it'll say your app will run on less than 1% of devices. If I pick something lower, now I'm up to 76%. I go down to maybe ice cream sandwich, I get 97.4%. So again, if I'm going to do cross-platform development with something like Xamarin or something else, this is still a choice that I have to think about, and there has to be a way for me to make that so I can decide who I'm going to support. Now, once you get through this, I actually have this project already created, and so I just wanted to show a little bit So first thing here in Android is I have this manifest which defines some things about that the OS needs for how my app is going to run. So what's the starting activity, what's my icon, things like that. And then of course I have code. Now because this is Android Studio, it's native, it's Java, so I have Java code. So this is the Java code behind my activity, which is just the term that Android uses for different screens and things. All right, and then for the actual UI, it's XML. But in Android Studio, I actually have a nice visual editor. So again, when we switch to Xamarin here shortly, am I still going to have this visual experience where I can design things in a nice sort of visual way? Am I going to have a palette of controls that I can choose from? Or am I choosing totally different controls? You know, things like that. So we can see here in Android Studio, it's a pretty good experience. We have a properties window. We can set things visually, but behind the scenes, it's XML. Now this is Android's schema as far as how to define the UI elements in XML. This is a native Android control, things like that. Okay, so experience is pretty good, but again, it's a specific language, it's a specific tool set if I'm doing native Android. Now, on the other side, if I'm going to do native iOS, it's actually a very similar story, but different, right? So I have language to choose from. I actually can choose Objective-C, which was the language for quite a long time, or now Swift, which is our newer option and the recommended option if you're doing native iOS development. And again, different development tools, Xcode, or there's even a third-party one from JetBrains called AppCode. So if I come over here and look at sort of the Xcode experience, so again, a lot of things are going to be really similar. So when I say give me a new project, I get to choose a template, you know, what kind of starting point do I want, product name, some sort of identifier that's going to uniquely identify my app, language. And so here's the iOS experience. So again, I have a file where I can sort of specify some application level things. So again, icon, what have you, and this behind the scenes is actually XML, different schema, different stuff, but very similar to what we saw on the Android side. I have a visual UI designer where I can do things like put stuff on the screen, what have you. And then, of course, for this user interface, I have code behind it. But again, now we're in Swift, and we're writing Swift code. Okay. So if I go to the third one, which is my Windows development, all right, and I'm going to say the Universal Windows Platform, which is our new way to target all sorts of Windows-based devices, whether it be tablet, desktop, phone, Xbox, all sorts of things. For that experience, you're in sort of the Microsoft .NET universe, so you're choosing C#, VB, or with UWP development, we could even do JavaScript or C++, and you're probably going to be using Visual Studio as your development tool. And so if you've done a lot of .NET before, this sort of experience is very familiar to you. Visual Studio, C#, yeah, right? So that's fine. So we could do that, right? We could build the application 3 times native using every vendor's tools and language platform, okay? But obviously, we want to know if there's a better way to do this, right? In that if I can reuse a lot of my code or use knowledge that I already have. So if I know C# and I know .NET, can't I just use that and build something that runs everywhere, okay? So for cross-platform development choices, we do have some options. We could build a web application. Pretty much every mobile device has a web browser. So they open up their mobile device, they open up a web browser, they go to our web app. Obviously, the advantages there is they're getting the most current version all the time because they're always downloading whatever content we have on the web server. And we can use HTML, JavaScript, CSS. If we know those different tools and languages, we can use that knowledge right at once. Obviously, disadvantage there, offline capability. They're visiting a website all the time. So if they're on a plane or something and they don't have an internet access, can't use your web app. And it's a web app. I mean, they don't have an icon on the home screen they can tap on. They don't get it from the App Store. They can't have a way to like review your app, things like that. So we could go with a hybrid application where it's still HTML, JavaScript, CSS, things like that, but it's wrapped inside of a native application. So they would go to the App Store, they would get our app, it looks like a native app, there's an icon, everything about it seems native, but it's really hosting web content that it can fetch from somewhere, or maybe even cache locally. Advantages there, again, it's more of a native feel, but you're still using web content. So some disadvantages, it's web stuff, so it looks like a web button, it looks like a web form. You're not using the native controls that are available on the platform. So if we go from iOS 10 to iOS 11, for example, and they change the way buttons look, our app doesn't change because it's web content, right? But depending on the kind of application you're building, a hybrid application might be a good choice. If it's simple data entry or you're just viewing information, something like that, it could be beneficial. So another option, though, is going to what we call native cross-platform frameworks. So in this case, we're actually building an application that is a native app. To the platform, it looks like a native app. We're getting native iOS buttons or Android buttons, text boxes, etc. We have access to a lot of the underlying platform capabilities, things like location, gyroscope, making phone calls, all those sorts of things. We have access to those APIs. So Xamarin is one, and that's what we'll be looking at here today, but there are others. React Native has got a lot of attention recently as they continue to evolve their platform, where you can use JavaScript to run everywhere. App Accelerator Titanium is another. And then Qt even provides some options using C++ to do a native cross-platform. So there are choices there. However, when you look at these different cross-platform choices, some things to think about. So advantages, obviously the ability to reuse code easily, right? Can we reuse all the code? Can we reuse a majority of the code, some of the code? We just have a lot more choices when we're looking at one of these cross-platform frameworks. Existing knowledge, so sure, if you really know JavaScript, maybe you want to consider one of the cross-platform frameworks that uses JavaScript. If you're a .NET C# person and you've been doing C# for a really long time, Xamarin could be a really good choice for you, so that we can use the skills and knowledge that we already have. You're sitting on top of the .NET framework, so if you know how to use HTTP client, you know how to use a link to query a collection, all that stuff's available to you. Even things like async and await now in C# that we can use, right? Some possible disadvantages just to think about, right, is even though you have the ability to share a lot of code across different platforms, you may still have to build the UIs multiple times if you want to get a really good platform-specific look and feel. So in other words, you can code all your data objects or model objects once, or do all your networking code once, all your file I/O once, but you may want to do the UIs separately because each platform has their own different design guidelines. You don't want your app to look like something different, or to look like you built it for Android and hey, it runs on iOS as well. You want your iOS users to feel like it was built for them, and your Android users to feel like it was built for them. And again, if it's a really simple application, that might be easy. You could potentially reuse a lot of the UI stuff. If your application is much more involved and takes advantage of a lot of the stuff that's specific to each platform, you may want to look at maybe building it twice. The good thing about Xamarin is it's going to allow us to have that choice, so we can actually do either, right? Some other things to think about, depending on the framework you're using, you may not have access to all of the native functionality. So if you're using one of the JavaScript ones, they provide some JavaScript classes and functions that then map to the native stuff, and different frameworks have different amounts that they'll support on the different platforms. In the case of Xamarin, we'll actually get access to all of the native APIs via the Xamarin platform, which is very nice. So some platforms, when a new feature comes out, may not be available in your cross-platform framework right away until they sort of release a new version and add those APIs. In Xamarin, we actually don't have that. as platforms evolve, we'll typically have those features available right away, which is really nice. And then, of course, performance and offline functionality. So when you're looking at a cross-platform framework, it's important to think about how is this app going to perform versus if I would have built this native, right? If you're using a framework where it's drawing its own controls and it's drawing its own UI, there's going to be an impact there versus using the native controls that are provided by the platform. All right, so we'll talk a little bit more about that, about how Xamarin does that when we get there. Okay, so before we actually dive into what Xamarin is and how it works and start looking at some code, I do have a couple sort of poll questions for you guys just to get a feel for where everybody's at. So just a couple quickies. So the first one here, how much experience do you already have with Xamarin? So I'm going to go ahead and, so we're getting some responses coming in. This is great. So we'll just give everybody a moment here. Okay, that looks pretty good. So let's take a look there. So majority, 54%, say none or very little. About 20% say they're familiar with it, haven't used it. We got about 20% says they've sort of done file new project and got it to maybe run, or maybe you've sort of got it to run, but maybe this emulator didn't work very well, or you struggled with that maybe. And then we got about 7% or so folks that have actually built apps with it. So that's good, nice mix there. So I got one more for you here. What are your future plans? So do you know you're going to be using Xamarin and you're just trying to get up to speed, or are you evaluating options right now? What are you looking at? This will be good. Cool. All right. That's about 75% of the folks. So yeah, pretty good balance there. 45, 30, 25. And then the very last one here we'll do is, because we can actually, I can switch back and forth and show a couple different environments, but if you're going to be using Xamarin to build some applications, what environment are you going to be using? So we got Visual Studio 2017 now, released just a short time ago. Visual Studio for Mac is still in preview right now, but it's basically what will be the replacement for Xamarin Studio on the Mac. Visual Studio 2015, you could still use it. The experience is a little nicer in 2017 now, just because we have better integration between the tools since Microsoft has acquired Xamarin. And then Xamarin Studio sort of being phased out and replaced with Visual Studio 2017 and for Mac. But currently, if you're doing development on a Mac and you don't want to use the preview stuff, Xamarin Studio is going to be your best option. But so let's see what we got here. So there we go. So the vast majority of folks say Visual Studio 2017, which is great because that's what we're going to be using here for most of the demos. And then some people still on 15, maybe because that's your choice, or maybe you don't have a choice. But as we'll see, some of the things have been smoothed out quite a bit in 17 now. Okay, cool, excellent. All right, cool, very good. All right, so I'm not going to do a lot of history here, but Xamarin's actually been around for quite a long time. It all started sort of with Mono, which was a version of the .NET runtime and framework to run on something other than Windows, so Linux. And so Xamarin started up around 2011, basically using Mono as the vehicle to sort of allow for cross-platform development using C# and .NET. We got Xamarin Studio around 2013, and then last year Xamarin was acquired by Microsoft, and so what we're starting to see now is sort of the tighter integration. And so just better error messages in Visual Studio, right? More visual help there, because there was an extension for Visual Studio that you could use, but there was only so much you can do via the extension mechanism in Visual Studio. So now we see with 2017, the Visual Studio team is actually bringing a lot of the Xamarin code in, and they're sharing back and forth, and so we're just seeing a more polished, better experience, and we'll see that in a second. So when we talk about the Xamarin platform, really comes in a couple high-level components. So when someone says just the Xamarin platform, usually they're talking about the core bits that allow us to write code that can run on Android, iOS, Mac, Windows, so forth. The compiler, the build tools, things like that. Okay, and we even can do F# now too with a lot of these. If you haven't looked at F# yet, it's different, it's interesting if you look at it, but most people are probably using C#. Xamarin Forms is our framework we can use to actually do cross-platform UI. So write the UI once and have it everywhere. Now we'll talk about that choice in a bit here, but we don't have to use Xamarin Forms, right? We can actually build our UIs native for every platform, or we can share the UI for multiple platforms. So I'll show both. Xamarin Studio, like I said, was the IDE, now sort of being transitioned to Visual Studio and Visual Studio for Mac. Okay, so Xamarin on iOS. Let's say we want to use Xamarin, we want to target iOS, but we really want to build our app native. We want to have storyboards and scenes and that sort of stuff. So I'll show that just one second. But one of the things about Xamarin on iOS is that Apple does make Xamarin's job a little difficult because they don't allow for runtime code generation. So if we're using C# and we're compiling to IL, Apple does not permit that IL to go on to an iOS device and then that IL be turned into native code at runtime. Okay, so what happens is when you actually build your Xamarin application, it'll be ahead of time compiled to ARM assembly that we can then deploy to our device. So it's transparent to you, the developer, but that's sort of behind the scenes what's happening there. And the framework components that you use from the .NET framework are actually embedded into your application. So it's not a case with most of the time when you do .NET development, the .NET framework has to already be there on the platform that your app is going to. Where here your app sort of carries with it everything it needs, right? The other sort of hurdle is that Apple's development tools are required to actually run an iOS app. So if you're developing with Visual Studio 2017, and you want to run your iOS app on a simulator, for example, you do actually need a Mac that you can connect to. And I'll show you how that works, but that'll allow you to actually run your iOS app on the device. Now, there are other options. For example, I didn't really mention it, but the last bullet there, the Xamarin Test Cloud, does allow you to sort of test your applications in a cloud environment where your app is actually running on real physical devices, and you can actually see the results on those different physical devices. So we got a couple choices. So let's take a look here. So I'm going to go over to Visual Studio. So here I am in Visual Studio 2017. Now I'm actually running Windows in a VM on a Mac, and then I also have a Android physical device plugged in, which is what's over here on the left, is we're viewing my physical device, and I can actually sort of bring it to life here. There's my Android device. So what I can do in Visual Studio is I can say File, New Project, and I'll get some options over here if I have the Xamarin tools installed as part of Visual Studio 2017. And so if I choose iOS, this allows me to build iOS applications using C# and .NET, but that I'm creating my UI using the native techniques and tools. If I choose Android, it's the same story. I'm building an Android app using C# and .NET, but using Android's XML, things like that. Okay, so if I do iOS and I'll say let's build a universal app to target iPhone and iPad. Say we'll go single view app, give it a name, give it a location, that sort of thing, and then what you'll get is something that looks like this. So again, I'm just targeting iOS at the moment, and so what we'll notice is yes, it's C#. So I have classes and namespaces and things like I would in any other C# application. I do have this info plist, and we saw that file when we were doing it in Xcode native. So this is that file that the OS needs to find out, what version is your app, what's the minimum target you want to support, icon, things like that. And it is XML. We could see that, but you get a nice editor in Visual Studio. And when it comes to my UI, I have a storyboard file, which is the native UI system for iOS. So if I was to launch my storyboard, the visual editor is very similar to what we saw in Xcode. I actually have a toolbox over here. I can drag and drop buttons and labels and all these sorts of things, but I'm building a UI the same way I would if I was in Xcode. And actually, you can use Xcode to build your UI and then bring that file into Visual Studio, and it will work because this file is the same exact format as if we were doing it visually. So this XML here is the same XML you'd get if you were designing your UI in Xcode. Okay, again, we're building a native UI, native controls. But when I'm over in my view controller here, my code behind, I can get at those controls and manipulate them using C#. I can bring in namespaces that are exposed to me in C#, which map to the native stuff, right? So I can do things like make a phone call or use core animation or do file I/O, core data. Basically all the stuff that's native is available to me here via C#. And I'll show you some more involved examples here as we move along, okay? But in every way, it's very, very similar to what we had when we were doing it native. It's just now we can actually write all of our code in C#, which is great, okay? And again, when I build this and then decide I want to run it, so you'll see here in Visual Studio, I'm actually connected to the Xamarin Mac agent. So this is something that's running on the Mac side, and the Xamarin website has really good instructions on how to get this stuff set up. But if I was to then launch this app, what it'll do is it'll actually communicate with my Mac via SSH and run the simulator on the Mac. In the past, the actual UI of the simulator would appear on the Mac. Now with Visual Studio 2017, in the enterprise version, it will actually allow the simulator visually to appear on your PC with Visual Studio. So in other words, you could just have a little Mac Mini just sitting on your network somewhere. Don't even have to have a monitor attached to it. But you'll use that as sort of your build server and your simulator so that you can run your iOS app, test it, so forth. Of course, obviously, at some point, we'd really like to run this app on an actual physical device. And again, there are good instructions. There are some sort of hoops you have to jump through there because apps, to run them on iOS, have to be signed and provisioned. But Xamarin has some really good instructions for that to actually get on a physical device. But the simulator can work really well just to see, hey, what does it look like? Is interactions going to work well? Things like that. So here I am running the simulator. Great. All right. So stop that, and we can set breakpoints. We can debug our code step by step. Everything that you'd sort of expect when working in Visual Studio. So that's really nice. Okay. Now, the flip side of the coin here. So we want to talk about Xamarin on Android. So same story here, but Android. So we're going to use Visual Studio, file new project, Android app, and I want to build my UI using the native Android stuff. Okay. Now, the good thing about Android is we don't have the same code limitations or code generation limitations that we do on iOS. So our C#, when we compile and build in Visual Studio, will get turned into IL, and it'll be packaged with the mono runtime, and it'll run on an Android device very similarly to how .NET applications typically run on Windows, for example. Okay, but it's obviously using the runtime that can run on Android devices, and it can handle the interaction with native types and things via the Java native interface there. So we can still write everything in C#. So what would this look like? Well, we can come back over here, and this time what I can do is I'm actually going to open up, by the way, this project, Hello iOS Xamarin, even though it's really just file new project, it is in the GitHub there as well. So I have another one here called Hello Android Xamarin. I'll open this one up. So same thing, I said file new project, picked Android, and we'll take a look here. Picked Android and said, I wanted a single view application for Android. And now I get something, again, looks really similar to what I had in Android Studio. I have my manifest file, which is here, which is that XML file that has things like, starting activity, icon, what have you. I have code, so here's my main activity, and so there's a little bit of starter code in there, but basically the same as what we had in Android Studio, but C#, right, instead of Java. And my UI. So I have an AXML file here. So this is XML, but Android schema, Android controls, so on and so forth. So same story here. I could actually build my UI in Android Studio to produce that XML, and then I could actually bring it into Visual Studio, or I could just open this file using Android Studio and work with it, and then be able to go back and work with it in Visual Studio, because what's actually going to be generated when we start dragging and dropping controls and things will be the same. So it's really nice, right? Yeah. Okay, so here's our UI. I can click things and do things visually. I have the ability to set properties like I did before. Obviously, it looks more Visual Studio than it does Android Studio. That's where we are. But I can still drag and drop controls and things, right, to design things visually. And then behind the scenes, I am getting that Android XML. So Android controls, so on and so forth. Okay. Now, of course, what we can do is we can create a project that has a Android app like what we're looking at here, an iOS app like what we just looked at, and then a third project where we can put all of our common code. So we can share code between the iOS and Android apps, but still build the UIs native twice. So we can build a really beautiful, perfect Android UI, a really wonderful, compelling iOS UI, and then just share all the common code when it comes to networking and I/O and all that good stuff. Okay, so let me go back over here for a second. All right, and when it comes, I'm not going to demo this, but for Xamarin on Windows, same sort of story here. We can say File, New Project, choose to build a UWP application, and then we'll get Visual Studio style tools like if you were building a WPF app, for example. Okay. There's also a .NET native option. So when we go to run our application on a Windows-based device, we're building IL. It's going onto the platform. The platform already has a .NET runtime because it's a Windows-based device, and so it'll use the runtime on that device, and the IL will be compiled, just in time compiled and run as if you were building a desktop Windows application. Okay. However, we can have this project with our other two and still use that common library across all of them. And that's really the point, right? So sharing code, as we've been talking about here, I took this quote directly from sort of the Xamarin documentation, which says, one choice here is you go ahead and build your UIs 3 times, iOS, Android, Windows devices. Sure, that's going to take some time and effort, but you can get a really good experience on every platform, native controls, all that. And then all the code that it doesn't deal specifically with the user interface, you share that code, right? But again, even when you write code in the UI for, say, iOS, it's still C# and .NET. It's C# everywhere. But some of that code we can just write once. Some of that code we write 3 times. Sure, good sort of middle ground, right? I'm not building the whole app 3 times, but I'm also not getting into that sort of least common denominator problem where I try to build the UI once and it's sort of bad everywhere, or I'm very limited in what I can do that works on every single platform, right? And so sometimes this is a good choice for Xamarin, is you go ahead and build your UI 3 times and then just share all that common stuff, okay? We do have another choice that we're going to talk about in a second here, but this can be a really good option. So what would that look like to do that kind of a thing over here in Visual Studio? Well, we'll say File, New Project, and this time we'll choose not Android or iOS, but we'll choose cross-platform. And so you notice in here I've got some choices, and one of them is cross-platform app, Xamarin Forms, or native. So when I select that and I choose OK, I'll get some choices. I'll say, all right, do you want a blank app or one that's already sort of master detail? Fine. But then down here underneath it says, are you going to use Xamarin Forms so you can just build your UI once, or do you want to build your UI separately, native? Okay. By the way, there are techniques you can use to actually even mix them. So for example, you can say, yeah, I want Xamarin Forms, but I want to embed into the iOS version an iOS control which is not available to me via Xamarin Forms. So you can all have native controls embedded inside of Xamarin Forms pages. So that is, we're not going to show that, but I just wanted to mention that that sort of thing is possible. All right. And then over here it says code sharing strategy. So do I want to use a shared project or a PCL? And we'll talk about that one a little bit here. But once I choose this, what I'll end up with is something, and I've already got one actually, that's in the GitHub as well. And so we've got shared project native. I'm going to open this up. So what I did is I chose that I wanted to do a cross-platform app, but with native UIs. Okay. So over here in Visual Studio, I have my solution, and I've got several projects. And I'm kind of doing multiple techniques at once here, but we'll look at each of them. So the first thing to notice is I've got my Android native app and my iOS native app. So these ones look the same as they did when I just created for iOS or Android. I have my info plist, I have my Android manifest, but notice the Android app does not have, well, yeah, we are doing native UIs here. So I do have my main XML for my layout, and I have my storyboard, because again, we're building native UIs here, right? And just to see, I got my Android one here selected, so I'm going to run my Android app on my physical device. One of the things I've noticed, the Android emulators, they work, but they tend to be just painful. Sometimes they don't perform very well. You have a couple options. One performs very slowly. There's a hardware accelerated one that's a little better. Visual Studio includes an Android emulator when you install all these tools as part of the installation. But what I found for me personally, it's easier just to get a physical device. You know, you can go out to your provide AT&T or Sprint or wherever, pick up an Android phone for $200. It doesn't even have to have a number or a connection, right? Because you can use it via Wi-Fi or what have you. And then if you plug your device in, you can actually use it right from Visual Studio here. So I'm actually launching on my physical device, and then I'm viewing it via this nice little app that's out there called Visor, V-Y-S-O-R. Just allows me to view the screen on my physical device. So obviously, if you were sitting here next to me, you'd actually see this on my physical device as well. This just allows me to show it on the screen. So yeah, so it's running. Okay. And again, I can set breakpoints. I can step through my code. It's C#. It's great. But again, I'm building my UI using the Android stuff. I'm building my UI using the UI stuff, the iOS stuff. Now, what about the stuff that I can share? Okay, so this is where we get some choices. Okay, so to share code across native projects. So again, if I'm taking this approach, I still need that native iOS project and that native Android project. How much code you put into those native projects can vary depending on your application, right? But we do need that because that has the manifest and the plist, and that's what's going to get built and then eventually signed. And sorry, I didn't show it, but I wanted to show that when I'm in my iOS app here and I go to project properties, this is where I can specify things that will get stored in that plist file. So things like which device orientations do I want to support? What are all the different icons that I need to specify? Things that are just specific to iOS, my deployment target. So how far back do I want to support for iOS versions, like we saw earlier? The nice thing with iOS, usually current major version and one major version back gets you 95% or more folks, right? And same with the Android. If I go to Android properties, this is where I can specify the minimum version I want to support, things like that. But these things are where you'd expect to find them, right? I'm in Visual Studio. I need to set some properties for my iOS project, for my Android project. It's in project properties. It's great. All right, so sharing code. The options we have here is we can do a shared project, we can do a portable class library, or we can use something new, which is called a .NET Standard library. And there are sort of advantages and disadvantages to all of these. And so I want to kind of talk about these a little bit so that when you're building a Xamarin app, one of the first decisions you're going to make is, am I going to build my UIs native? Am I going to use Xamarin Forms? How am I going to share code? Am I going to do shared projects, PCLs, .NET Standard? Okay, and again, depending on your app, you may want to choose one over the other. So shared projects, how this works is you write code in a shared project, and when you build your apps, that code will literally be copied into each project and compiled in each project, right? So if in Visual Studio, I decide to have a shared project, which I have here, this one here, it says shared project native. I have a class in here. This doesn't get built into anything, okay? There's no properties on this really at all. It's just a container for files. And when I build this solution, this myclass.cs will be copied into my Android project and compiled, copied into my iOS project and compiled. So in here, I can have a class called myClass. I have a message called getMessage. I can add a reference to this shared project. So in iOS here, I have a reference to it. And in Android, I have a reference to it. And so now I can use that class in my native projects. So for example, in my view controller here in iOS, I say MC equals new myClass and set the text of the label to whatever comes back from that method call. And so in Android, I'm doing the same thing, creating an instance of that class, calling that method. And when I ran this in Android, you probably saw that it said hello from shared project, because that's what I'm returning from that class, right? Now, the advantage here is it's very easy to set up. I can just say, I'd like to add a new project to this solution and choose that I want to add a shared project. It's there. And I can put code in there. But that code has to be able to compile in both, right? Now, what about stuff that's a little different? So for example, I'm writing code in my shared project, but it needs to do something a little different if I'm running on iOS versus if I'm running on Android. So if I was using a shared project, what are my choices there? Well, you've got a few. These are described in pretty good depth in the Xamarin documentation. But one choice is I can use conditional compilation, where I have some symbols defined in my projects. And I'll just flip back over here for a second. If I look at my iOS project and go to my build settings, you see I have some conditional compilation symbols defined here. So these are defined in the iOS project, and then I can also have different symbols defined in the Android project. So then in my shared project, I can write code like this, right? Which I've got some property that's going to be giving me back the path to the database file. So this method exists in the shared project. However, when this file is being compiled in the iOS project, it includes the iOS code here, and when it's being compiled in the Android project, I get the Android code. All right, so I'm just choosing which code to compile. If you've done any cross-platform sort of things, you may have done a bunch of if-defs like this and things. I just need to accommodate a few things in a few places, this can work great. Once I start doing this a lot, I want to think about maybe there's a different approach, right? Because this code can get a little ugly, and now you've got platform-specific code in the shared project, which is not really where I like it to be. Okay, but it can work really well. Again, if most of the code is the same everywhere, you just have a couple little places here and there where you need to deal with that. You could use partial classes and methods. So a partial class is defined in your shared project, and then you define more of that class, another partial class, in the native ones. I don't really like that technique. Partial classes are a little bit kind of hurt readability, and they're a little harder to follow, but that is a technique you can use. Or we can choose not to use shared projects at all. We can use something called a portable class library. So with this, is you're actually adding a project to your solution that compiles into a DLL, and you're going to add a reference to that thing. Okay. But because this thing's going to be linked to and used in iOS and Android, there's a subset of the .NET framework that we can support. So when we build a new piece, define a new PCL, we sort of choose which platforms do I want to support here. So what I've got in our example project is I also have a portable class library. So again, I can go to my project, I can say a solution, add new project, C#, and say I want a class library portable. And when I do that, I will have the option to choose platforms to support here, right? So I'm saying Xamarin Android, Xamarin iOS, and so the system will automatically restrict me so that I can only use things that are supported everywhere, okay? So, and then I can add a reference to this PCL from both places. A lot of packages that are on NuGet that you can use in Xamarin are PCLs, portable class libraries, okay? So I have another class here in my PCL called my other class, and then I could use that from both my Android app and from my iOS app. Just, again, add a reference like you would use any other .NET class library, and then you can use it. So I had some other code in here where I use that one instead. So instead of using this one, we'll use this one, all right? So now I'm calling the class that's in the portable class library. And I could set this as my startup, and I could run this guy. All right. So now, why would you choose one over the other? Well, with the shared project, because that code's being sort of compiled into each, you have to be sort of a little careful of what you're doing in there. And it's just, we start to get into those conditional compilations and things, and it's just not a very sort of object-oriented way to design your stuff, right? Shared projects is I'm just writing it and I'm copying it into both places, and I'll just, you know, specify with some if statements of where to do things. If we're using a PCL, then we can start using some techniques like dependency injection, where the class library can define an interface. It says we have a thing that does this job, and then each native project can define a class that provides that implements that interface, right? So then I can have, you know, all my interfaces and all my common code are in the shared library, but nothing that has to do with any platform. Then each native project can define the functionality, right, the implementations of the interface, so that the platform-specific code is in each platform-specific project. It's a little bit better separation of concerns there, a little bit cleaner approach. So for me, a lot of times I prefer the PCL approach. But when you're looking at examples on the web, you may get an example project from Xamarin, and they may be using a shared project. So you should recognize sort of what it looks like and sort of how it works, right? The PCL approach, though, is typically a better option, right? So I just want to mention briefly that PCLs are sort of being replaced. So we now have something called .NET Standard. And the idea with PCLs really was, if you're a library writer, you want to write a library that as many people can use as possible. So I want to write a library that my Xamarin friends can use, and my Windows developers can use, and my ASP.NET web developers can use, my Silverlight folks can use, everybody. So PCLs solved that problem by saying, okay, we've got our .NET Framework people, our .NET Core people, and our Xamarin people. And so when I build a PCL, I can choose who I want to support, and sort of it'll give me that intersection. So the stuff that's only supported everywhere I want to target. The problem was it just sort of got a little difficult to maintain, and as these different stacks sort of revved, PCLs had to have new profiles, you know, new combinations and intersections, and it worked, but it was just a little cumbersome. So .NET Standard says, why don't we just define a standard set of functionality that everybody will support? And so if I'm building a library, I can just build my library to target .NET Standard, and then every app model that supports that version of the .NET Standard can use my library, okay? So Microsoft is just trying to clean this up a little bit and make it just a little bit easier. So for example, if I'm building a library and I want to put it on NuGet, I build a library that targets .NET Standard 1.2, and now I know people that are using .NET Framework 4.5.1 or Windows 8.1 or what have, they'll be able to use my library. Okay. Now, the transition to .NET Standard is not complete yet. It's still sort of a work in progress, and so you can use it in a Xamarin application. So I have a third project I added here called Shared Standard Lib. So what I did here is I said add new project and choose .NET Standard and create a .NET Standard library. And then I can add a reference to this from my Android and my iOS, and then I can use that. Okay. But there are a couple little wrinkles with it still. So for example, in the GitHub page, I did put a couple links in here to issues with using Xamarin Forms with .NET Standard Library and with debugging a .NET Standard Library. These are issues that are on bugzillaxamarin.com, where one of them is still an issue where if you try to put your Xamarin Forms UI in a .NET Standard Library, you have issues. But they fixed that for the next release of Visual Studio. And then another issue where when you're debugging into a .NET Standard Library, and I'll give you guys this to maybe save you a little bit of time. If I go to my .NET Standard Library and go into my properties and build, this debugging information defaults to portable. If I change that to full, it'll resolve errors that you may get. So the default setting doesn't work quite right, but we can overcome it. So I provided those links there in the GitHub page, so if you want to look into that yourself, you can. Okay, but I can use the standard library. I have another class, and then I can use that. So difference between PCL and .NET Standard, they're pretty much the same. They pretty much do it the same way. Just one is sort of the newer, cleaner approach. So if I'm building a new Xamarin app today, you can use .NET Standard. You may just have to overcome a couple of these little issues with the tooling. So if I'm building something that I'm going to release 6 months from now, I'm probably going to go to .NET Standard. If I'm building an app today that I'm going to release 2 weeks from now, I probably want to still go with a PCL, just because the tooling and things will be a little bit nicer. Okay. Now, last thing I want to mention sort of briefly here is everybody always asks about it. What about my UI? So you just showed me how I can have native apps and share all the non-UI code. What if I want to just write the UI one time? So Xamarin Forms is our cross-platform UI framework that is provided from Xamarin, and we can actually use XAML. So if you've ever done any WPF development, it's pretty much the same thing. And so you're writing XAML for all the platforms. And what Xamarin does is they basically have this, there's a reference here of these Xamarin controls. So activity indicator, box view, button, date picker. It shows you what they look like on all the different platforms. But what happens is when you use a Xamarin Forms control, it turns that into the native controls at runtime. So even though you're using a UI framework that runs everywhere and you're just writing it once, you still get the actual native platform controls on each platform at runtime, which is great. So you get good performance, things like that. But you don't get everything. So these are all the Xamarin views that are available. And so if you're doing a list view or something, it works great. But if you need something more involved, there may come a time where you say, well, no, I really need to build the UI separately. It just depends on your app, right? So what I have in the GitHub is I have another project. And what this is it's called Northwinder, because it actually uses the Northwind, Microsoft Northwind sample database. And here I'm pulling all the pieces together. So you're free to sort of look at the source code for this in the GitHub or download it yourself. But basically what we're doing here is I created a new project, and I said, when I said file new project, I went with cross-platform, but then I chose to use Xamarin Forms and a PCL. Okay. So let me go back and open that up again. So I've got 3 projects here. I've got my native Android, my native iOS, and then my common code. Now what this application does, let me go ahead and run this on iOS just to give you an idea of what's going on here, and then you can dive into it further and take a look at what's happening. But I'll run this. Now what it's doing is it's starting my Mac agent so I can run my iOS simulator, which usually when you first open a project, it just has to, communicate back and forth and what have you. But we'll run this. And so what this application does is when it launches up, it's going to communicate via a web service, retrieve some data from the web service asynchronously, turn that JSON data back into objects, and then display those objects in a Xamarin Forms user interface built using XAML. But all the networking code, all the file I/O code and everything is all shared. So when it comes to file I/O, once I fetch the data from the web service, I want to store that data locally on the device. So next time you run the app, if the web service isn't available, I can load it off the local drive. So all the networking code is common. I put that in my PCL. I call that from the Android app and the iOS app. So up comes the app. I'm going to load my UI, make my asynchronous web service call, and we're going to display some products here. These are all coming from a web API that returns JSON data, right? Get a nice little master detail here. This looks like an iOS app, even though it's built with Xamarin Forms. So let me stop that. So here's my iOS app, and now there's no UI in here at all. All it has is basically the startup code, which turns things over to Xamarin Forms. Now, in my PCL, I have my Xamarin Forms stuff. So for example, my product page, this is Xamarin Forms XAML, where I can design my UI. Now notice I don't get the nice drag and drop visual designer here. I don't get the nice toolbox. I'm writing more of the XAML myself, but this allows me to write the UI one time, okay? And in here I also have my repository. So this is where I'm actually making the call to the web service, but I'm using C#, I'm using HTTP client, I'm using async and await to make the web service call, deserialize that using Newtonsoft JSON, if you've done that before with C#, and then delivering it to my UI so that it can be displayed. Now when it comes to the file I/O, each platform does it a little differently. So in my portable library, I've defined an interface called iLocalCache. It says I need to load some stuff from the disk and save some stuff to the disk. So this is defined in my shared library. But then each native project can define an implementation of that. So here's my iOS one. And so what this is doing is it's using an NS file manager, which is an iOS specific type to actually get the URLs and do whatever it needs to do and save and load. And notice up here I have this attribute that says this is a dependency. So it's using Xamarin dependency injection. So in other words, when the app is running and I say I need an iLocalCache, I'll actually get this one. Now in my Android app, I have the exact same thing. Okay, get this. So back over in my repository class, notice right here where I say this dependency service get an iLocalCache. So in other words, in my shared project, I'm saying, hey, I need an iLocalCache thing. If it's my Android app that's running, I get the Android one. If I'm in my iOS app, I get the iOS one. But it's the shared project that's sort of running the show here. It does all the common stuff, like making the web service call, and it actually does the writing or reading from disk, but uses the implementation provided by the iOS project or the Android project. So this is using dependency injection with a portable class library. So this is sort of, most people consider this a more advanced thing, right? But I wanted to get this in here to this webinar because, you know, if I'm creating a project it's going to take me months and months to build, and I want to architect this thing really properly, this is probably the way I'm going to be doing it. Because this way I can have all the native specific stuff in each native project. I can have all the shared code over there, and I can sort of do that in a nice, clean, separated way. Okay, but still, in this case, just build my UI once. Which, again, the decision about Xamarin Forms versus native UIs really depends on your app. And for that, you kind of have to build a few apps using Xamarin Forms, see what it's capable of, see if it works, and if that's going to be good for your app. Or you might say, no, I've used Xamarin Forms a little bit, it's really great, but for the app I'm building, it's just not quite going to get me there. I'm going to have to build my UI separately, but I can still share all the native code for, again, networking I/O or model objects, whatever it happens to be. Okay, so again, this project here is in the GitHub. It's that one called North Window here. So you got all the source code for that. Now, if you were to download this guy and open it in Visual Studio and click run, just a couple quick things. You probably want to do a rebuild right away just to sort of clean and start from scratch. And some of your references may be off. If you may just have to re-add a reference or things like that, just because my environment's a little different than yours, but all the code is there. Also, on the Xamarin website, they have lots of really cool full-featured examples as well. And when you look at the samples, you'll see they'll usually say, this sample uses Xamarin Forms. This sample uses native UIs. This sample uses PCL. This sample uses a shared project. Because really, you know, depending on what you're building in your specific app, one solution may be the right answer in one case. In another case, the other option is actually better. All right. So, yeah, and I have a little bit in here about Xamarin Forms. But one thing I do want to mention with Xamarin Forms, what if you're building your UI once, but there are little things that are different? They thought about that. They provided you some really nice, easy, clean ways to do that. So on the slide here, I just show that they have a device.onPlatform. So you can say, execute this code if we're on iOS, execute this code if we're on Android. Or even if you look down at the bottom there where it says new thickness, that's code in my XAML. So I'm saying this thickness thing for like doing a margin or padding, and I have device on platform right in the XAML. So I can say, sort of a shorthand way here, it should be 20 points on iOS, 0 points on Android, 0 points on WinForms. So again, if your Xamarin Forms UI looks almost right everywhere, but a couple things are a little off, you can just put these things into your XAML to handle that, all right, for what to happen on each one. And then if it starts getting really different, maybe Xamarin Forms is not the best. Here's just another example in Xamarin Forms of, I've got a background color here on a layout, a stack layout, and I'm saying on iOS it should be silver, on Android it should be green, on Windows devices it should be blue. So again, really nice just to handle those things that are a little bit different. So if you're building a new app, I might say consider Xamarin Forms and a PCL, and you know, maybe do a prototype, try to use some of these techniques to handle the differences, and if the differences start to get a little out of hand, you have that ability to just switch over and build the UIs native for each platform, but still share all the rest of that code, which is really, really nice. Okay. All right, so a couple things. One, there is a recording of this webinar that is being made, and so you will get an email afterwards. It takes a little time to kind of get the recording up there and everything, but you will get an email that will give you access to this, so you can watch it again. The GitHub address, again, all the code, that'll be up for probably a week or two at least, if you want to look at some of that. And then we have the 2-day instructor-led training I mentioned earlier. In there, we will spend half a day on Xamarin Forms and talking about what you can do in XAML, how it's different than WPF in some cases, but things like data binding and animations and triggers and styles and those sorts of things. Okay. My email address I have up here. So we want to take a little time here to do some, if anybody's got some questions. However, we also have quite a few people. So if I can answer some questions that you want to put via the chat window, that's great. But also you can email me if you want. And if it's something where I can just respond back and say, oh, yeah, this example over here shows that exactly, and just give you a URL, I'm happy to do that. Or just sort of point you in the right direction, or I can say, yeah, that's a known issue. Here's a link to the bug report on Xamarin.com. We can do that too. Okay. So with that, if anybody has any questions they want to sort of shoot out there, just use the chat window in the GoToWebinar interface there if you can, and just chat that out, and we can address some questions. All right. And I'm looking. Don't see any. take a look here. Okay, so all right, I got a couple. So Xamarin versus React Native. Which path to choose? Important decision factors. All right, so really the prime factor there of React Native versus Xamarin is going to be the language. Okay, if you're going React Native, you'll be using JavaScript. If you're going Xamarin, you'll be .NET, C#, or potentially F#. So if you have a lot of experience in one versus the other, that's going to be your primary first factor. The other factor is that with React Native, you have these JavaScript libraries and methods you can use to get at the native stuff, but they provide basically the things you would probably need, but you don't get sort of everything. So the API surface area that's available to you is a little bit less or lags a little behind with React Native versus Xamarin, but depending on your app, that may not matter. So you should just look and sort of see, all right, what's available to me here versus what I'm used to in the .NET frameworks. Again, if you've used the .NET frameworks before and you know how to use things like HTTP client and lists and queues and stacks and link and async await and all that great C#.NET stuff, then you're probably going to lean more toward Xamarin. But again, it's a simple app. Again, they both can work really well. Your user won't know the difference. When they download the app from the App Store, they can't tell whether you used React Native or Qt or Xamarin because it'll look the same on their end, because you do get native controls in both cases. Does that also work with a real iPhone connected to a Mac? Yes. So running your application on a physical device, if you have a physical device connected to your Mac, you can run it on the physical device from Visual Studio, for example. However, to do that, you do need to have a provisioning profile, and the app needs to be able to be signed. So what you do is on the Mac, you actually open Xcode and you configure, I'll just really briefly, I'll just pop up where it is. If I go over here to Xcode and I go into Xcode preferences, this is where I can configure your Apple IDs, or if you have an account with an Apple developer account, this will need to be configured, and you'll need to have a provisioning profile, what have you, so that the app can be installed onto the device. Okay, so there's good instructions on the Xamarin website for that part as well, showing you how to do that, but you can do that. And then when it comes time to actually deploy your app to the Apple App Store, for example, it's going to be the same sort of thing. You'll use Xcode to configure these assets, and then Visual Studio can actually get at those assets and be able to sign your app and deploy it to the device. So once you get your account set up and everything, you can still just click Run in Visual Studio and it'll launch on the iPhone. Yep. So the follow-up to that was, will the screen of the real device show on the PC? I'm going to say no to that. The sort of remoting of the UI onto the PC is just through the simulator. I haven't played with that a whole lot because that's brand new now in Visual Studio 2017. But no, it won't. But what you can do is you can use, if you use QuickTime on the Mac, you can actually get the physical device to appear on the screen of the Mac, and then you could maybe remote desktop to that from the PC. So you could get the screen on the PC, but you'd probably be jumping through some hoops. Yeah. Can one specify custom UIs for Xamarin Forms projects? So what your option there is, you can choose native, and then you're building everything native, or you can choose Xamarin Forms, and if you choose Xamarin Forms, you can embed native controls within a Xamarin Forms XAML. So here in the XAML, I would need to add some additional namespaces and things, but then inside the Xamarin Forms XAML, I could literally just say right here, I want a UI table view, which is a iOS specific UI control. And then you set the properties with attributes to control that iOS table view. But what you cannot do is you can't, for example, have a Xamarin Forms page that when you click on a button takes you to another page that was built native. What you do is the Xamarin Forms page would take you to another Xamarin Forms page that has inside of it native stuff. But if it's a Xamarin Forms app, the root view of every screen has to be a Xamarin Forms content page or navigation page or something like that, and then it can have native stuff in it. But because of the way the sort of the app model works in event handling, you can't sort of flip back and forth at runtime between the two worlds. Okay. Can one still do MVVM when building platform-specific UIs? Absolutely, for sure. So you can either define your view models in your common library and then have that be delivered for display in your native UIs, or you can define the view models in each native application. So all your models can come from your shared libraries. You then populate your view models in your native, which you can then either which you can use from the native UIs as far as data binding and things like that. So you can bind to view model properties both in iOS and Android, or Xamarin Forms as well. So you can absolutely do that, and then where you put your view models sort of depends on you. One question that I think I answered, but somebody asked, will the recorded video be made available later? Yes. You'll get an email that'll have like a survey and things, and then they'll also give you instructions there as far as how to view it later. Is Xamarin Forms slower than Xamarin Native? It depends. You do with Xamarin Forms, you are still producing native controls. So for example, let's say the scroll performance of a table view. So you've got a list of items, and you populate that thing with 10,000 items, and I'm flicking through it with my finger. What's the performance of that going to be like if I'm doing a native UI, or if I'm doing Xamarin Forms and a list view? They'll be the same, because the Xamarin Forms list view, when it sort of creates the form, will create a UI table view control on iOS, for example, and it uses its cell recycling techniques and everything that's native, so that scroll performance will be identical. Now, on the other hand, let's say you want to draw something custom. So I'm going to draw something on the screen, or I'm going to do some animations or something. If you use Xamarin Forms for doing some more of that low-level stuff, the performance may not be as nice as if you were using on iOS. It would be like the core animation framework to do some of that. So for just building UIs that use the built-in controls, the performance will be the same. But as soon as you start doing really custom things, then doing it with the native stuff may be a little bit better than what you get from the Xamarin Forms stuff. But it's kind of a case by case. But like I said, with the built-in controls, they'll be the same. Xamarin Studio available in Visual Studio Professional or Enterprise Edition. So basically now with Visual Studio, every version has the Xamarin stuff in it. So you could get Visual Studio 2017 Community Edition, which is the free one, and you'll have all the Xamarin stuff, except you will not have the remote iOS simulator. So you won't see the screen of the iOS simulator remoted to your PC unless you're running Enterprise. And what else? And then there's a few other things in Visual Studio, like live unit testing and some other things that are enterprise only. But everything that we've seen today, except the remoted simulator, is available in all versions of Visual Studio. And again, it's sort of replacing Xamarin Studio. So going forward, Xamarin Studio is going to sort of go away, and it's just going to be Visual Studio with all the Xamarin Studio bits in it, right? How does things like iOS auto layout handled by Xamarin? So with that one, and let me just see the rest of the question here real quick. Auto layout, so if you're doing the native stuff, so you're building a Xamarin application and you're doing the native UIs, you're going to get the same native layout pieces that are available to you. So like in iOS, for example, with all the auto layout stuff, if I go over here to my project, see if I can do this real quick here, iOS native, and I open up my storyboard in Visual Studio, the UI is going to be a little different, but the stuff is there. So you can actually add constraints. You'll get properties on constraints. You can change it in the designer to see how your constraints behave. All the auto layout stuff is there. If you're using Xamarin Forms, then Xamarin Forms is using the XAML-based stuff. So it has things like stack layout containers and the things you have available in XAML. So you can still achieve a adaptive responsive UI, but you're going to be using the stuff that's provided by XAML for how that stuff is laid out on the screen. So you won't be using the auto layout infrastructure that's provided like when you're doing it in iOS with constraints and things. So it just depends on what you pick. So yeah, so here I am in a storyboard with doing a native UI. And so if I actually were to click on this and go to properties, for example, and things, you will see the ability to do, if you've ever used Xcode, you'll see stuff that looks really similar. So either you can use the old style with kind of springs and struts, or you can actually add constraints as well, like you have in the newer versions of iOS. So it is there. It's just you have to figure out kind of where to click around if you're used to what Xcode does. Is it okay to develop a Xamarin app that only calls a website? Sure. You could use Xamarin to build a hybrid style application. Basically, you can. There is a web viewer control that you can use in Xamarin Forms, for example, to bring in and display web content. However, generally the recommendation is that you use the web controls for doing things like showing your help documentation or marketing type stuff, things like that. Not to build your whole entire UI that way, just because you start to lose things like the accessibility features on the different platforms. So like on iOS, if you turn on some of the accessibility features where it'll sort of speak the names of controls, and there's accessibility for people that have a hard time keeping their finger in one place on the screen for a period of time, so it'll alter that a little bit, and so you lose a lot of that stuff when you just use web content as the UI of your application. So there's nothing wrong with it. Apple will not reject your app if you're just displaying web content, but if it's a very simple app, that might be okay, but I'd sort of recommend against that. For the most part, just because of a lot of things you lose. And since I can use something like Xamarin Forms, it's not that much more difficult than HTML. It's a little different, but then I can keep a lot of those features intact. When it comes to localization and things like that, get easier too. Let's see what else we got here. It seems like you need to know differences between iOS and Android. Yeah, they're different platforms, right? Xamarin made the choice that when you're building cross-platforms app, you want them to look great everywhere. And so they really want you to learn about the iOS platform and the Android platform. How are things supposed to look on Android? How are they supposed to work on iOS? And then share the stuff that's okay to share, but don't overdo it, right? So Xamarin's approach is basically, how can we give you the maximum amount of reuse but still having your end result look like you built it native for every platform, okay? And so, should you go learn Android Studio and should you go learn Xcode? Maybe not, but you should still definitely learn sort of what the patterns and practices are and things for each platform. So I'll show you just for example, if I go to the Xamarin documentation, they do a really good job of that, where you'll say, all right, this is for if you're doing iOS, if you're doing Android, and Xamarin Forms. So if I click on iOS, for example, the Xamarin documentation has a lot of really good stuff in here about things like application fundamentals. How does threading work on iOS? How does graphics and animation work there? How does backgrounding work when your application runs in the background or is in the foreground? What are the different life cycle events that your app goes through? And the same thing, if I flip over to Android, it's going to have the exact same topics, but how it works on Android. So now, even if you're doing Xamarin Forms and you're trying to build your UI once, it's still good to know how this stuff works and how to best interact with the platform, right? So yeah, you still need to know about the individual platforms, and if you've got a physical device of each, that even helps too. So maybe we'll do one or two more and then we'll wrap it up here. Any plans to natively support other devices? So Chromecast, Roku, and Amazon Fire, things like that. Nothing official that I know of. Basically, right now we're looking at all iOS-based devices. So there is support in Visual Studio for the Apple Watch, of course iPad as well as iPhone, Android Wear, Apple TV. More may come later. Some of that just depends on sort of how much assistance they can get. Like, I'll give you one example. there is support with Xamarin to actually develop for Samsung devices like televisions and things. I'm trying to remember the name of the framework, but there's another SDK that you can actually download and install, and then you can actually develop for their stuff as well, because Xamarin worked with Samsung to sort of add that to the platform. So others may come along as Xamarin gains more popularity. We may see more added. But right now in Visual Studio out of the box, it's just all iOS-based stuff and all Android-based stuff. Does Visual Studio for Mac have a release date? Nothing official. I've seen some folks asked about that many, many times, and they're very sort of coy and secretive about it. We're getting close. I mean, if you've used Visual Studio for Mac, I'll just see if I can actually pop it up here. Let's see. Yeah, Visual Studio Mac. So the experience, I'm not going to go through the whole thing, but Visual Studio for Mac is going to give you experience that's really, really close now to Visual Studio on Windows. It's Mac app, so something's a little different. But yeah, as far as release date, if I had to just totally guess, I'd say you're probably going to see it in the next 30 days. But again, they're really careful about saying anything official. So, but you see in Visual Studio for Mac here, I get the same sort of choices, whether I want to do cross-platform, native. The only thing you cannot do in Visual Studio for Mac is you cannot develop for Windows platforms. So you cannot do a UWP project or a WinPhone project here. So in Visual Studio you can do everything, but you need a Mac to connect to. On the Mac, you can do everything except the Windows stuff. So you sort of have to choose there what you want to do. Okay, and there's an Android emulator for Mac. It works actually pretty well. I think cool. I think we'll stop there. So again, if you asked a question and it did not get answered because there was a bunch of them in there and stuff, again, feel free if you want to just maybe shoot me the email and I can sort of maybe give you a little something back. Okay. Other than that, I think we will conclude it there. So thank you for attending this, and if you can maybe take a look at the 2-day, we can go even deeper, or if you're interested in maybe doing a full 5-day on-site with this stuff, we'd be happy to talk to you about that as well. Other than that, thank you for your attention, and see you later. Bye-bye.